Hey guys, this is Mr. Grice for Algebra Unit 8.4 Notes. Today we're talking about solving quadratic equations by using inverse operations. Our learning target today is to be able to solve quadratic equations by using inverse operations. So 1, 2, and 3 are a review. I'm feeling nice today, so we'll go through them together. It says to solve the quadratic equation by factoring if possible. So I need to look at my quadratic term, and I want it to be positive. We want everything to one side. So if I want my quadratic term to stay positive, I need to move the smaller one, which means I'm going to move the x squared to the opposite side. And so everything's going to the left. If I'm moving the x squared, I need to move the 3x as well. And then let's see what we get. Our terms on the right all cancel out and we get the 0. And then we're left with 2x squared minus x squared is x squared. It's positive. The 3x doesn't have a partner, so we're writing it in standard form. So it comes next. And then minus 40. Well, from this point, we want to factor it. So I'm looking for numbers that multiply to get to negative 40 and add to get to 3. And that would be a negative 5 and a positive 8. Okay? Now, I don't have to split the middle term here because our leading coefficient is x. So we get x minus 5 and x plus 8 equals 0. And remember, we're solving. So when we solve that, we set each one of these x minus 5 equal to 0 and x plus 8 equal to 0. And we get our answers of x equals, our left one, x equals 5, our left one, x equals negative 8, and we write that in order. We get negative 8 comma 5. Okay? Let's look at example number 2. Now my quadratic term is the 7x squared. It's the only one. So once again, I need to move everything to the left. Okay, everything on the right cancels and we get our 0. And then we get 7x squared minus 14x, and then negative positive 2 minus 2, those cancel. Well, how do we solve this? The quadratic binomial, the first thing we always look to see is there a GCF? Well, right away they both have x's, and I know that 7 can go into both of those. So I'm dividing them both by 7. My GCF goes out front, and then I write the remainder inside. And so that's x minus 2. I set everything with a variable equal to 0. So 7x equals 0 and x minus 2 equals 0. Those two answers are x equals 0 and x equals a positive 2. If you're not seeing how I get that answer, guys, you need to rewatch 8.3 notes. Okay? All right, last one. What's our quadratic term? Well, I've got 2. So which one's bigger? The 8's bigger and it's positive. So that means I want to move everything to the right. So I'm going to subtract the 3x squared and I'm going to subtract the x. Those cancel. We get a 0. And we get 5x squared. Up, our x's cancel too. Minus 10. So what would we do now? Well, we'd check. Is there a GCF? Yeah. I can take out a 5. And so the GCF comes out front and we're left with x squared minus 2. Now, can I solve this by factoring? Sorry guys, this can't be solved by factoring. And that's the key thing. I said it can't be solved by factoring, but this can be solved. And so today what we're talking about is solving quadratic equations by using inverse operations. There are 4 ways to solve. And so far we've only talked about factoring. Okay, we know that we're not done factoring until there are no more quadratic terms. And example number 3, there's still a quadratic term there. So what do we do? Now, our rule says that we had 0 equals 5x squared minus 2. To set everything that has a variable equal to 0. So 0 equals x squared minus 2. How would we solve this? 6 of your favorite letters. SADMAP. And SADMAP stands for inverse operations. Okay? Now, inverse operations, once again, that is SADMAP. And it can only be used if a quadratic equation, if it does not have a linear, oh, A is already in there, a linear term. And you guys are probably like, Mr. Grice, come on, man, I don't remember what a linear term is. Let's be real. Okay, let's review. X cubed, that is a cubic term. X squared, we're going for our big words here, is quadratic. X, that would be x to the first, is a linear term. And if we just had a number, no variable, that's a constant. Okay? So we cannot have a linear term. Is there a linear term just a variable? Nope. So we can solve it. That's great. But what do we do next? Well, let's talk about some of the most common inverse operations. There is addition and subtraction, multiplication. These ones should be reminders right now. Multiplication and division, and then exponents and what's the partner for an exponent? Well, let's take a look. Can you guys see? I know it's hard for so you guys can see what I'm actually pointing at right here, but my x squared button, what's above the x squared? The square root. Okay, it's exponents and roots. So if we were to move on to this example or just continue, I would use inverse operations to get the x by itself, and we get 2 equals x squared. And then to solve it, the opposite of a square is a square root. And then whatever that ends up being, that would be my answer. Okay? So let's go back to our notes. When solving quadratic equations, if you square root a, let's give an example real quick. Let's see how smart your calculators are. How many answers are here? X squared equals 9. Well, Mr. Grice just said that to get rid of a square, we would do the square root. So when I plug this into my calculator, I want to know what is the square root of 9? 3. So my answer is 3. But is that my only answer? We're thinking, what number squared equals 9? And if we plug in 3, that's true. But guess what? Is there another number here? There is, because what's negative 3 squared? Negative 3 squared is 9 as well, guys. So here's a little reminder. If you square root a positive number, the equation has two real solutions, okay? And it's going to be a positive and a negative. So the way we would write this would be x equals plus or minus 3. And that stands for x equals negative 3 and positive 3, however you want to say it, okay? These both mean the same thing. All right, let's try that with a negative number. I'm sorry, not negative number yet. We're on 0. So our next example, x squared equals 0. Well, just like Mr. Grice said, solve by inverse operations. The square root of 0 is 0. Is there a negative 0 to multiply itself by to get to 0? No, guys. If you're taking the square root of 0, it only has one answer, and that answer is 0. Okay? Because it doesn't have an opposite. And then the last one, if you square root a negative number. So let's see what happens when we take the square root of negative 9. So I have to take the square root of both sides. So square root of negative 9 equals, oh, well, why is that? Well, because there's no number that I multiplied by itself to get a negative 9. Okay? Even negative 3 times negative 3, that equals a positive 9. No number by itself will ever get you a negative number. No real number. So the answer here, the equation has no real solution. When you move on to Advanced Algebra 2, you'll learn what some of those solutions are, but not right now. So we have to solve the quadratic equation, and it says to round square roots to the nearest hundredth. So we said there are two ways to solve. And the two ways to solve is one is by factoring, and two is by using inverses, the SAD map. If we were to factor, we would want it set equal to 0, correct? So to get this equation set equal to 0, I would subtract 16 to both sides and get x squared minus 16 equals 0. And that is a quadratic binomial. Quadratic binomials means that I can take the square root of both of those and get x plus 4 and x minus 4. And now that I can do that, I end up getting that my answer is x minus 4 and x plus 4. Woohoo! I got my answer. But Mr. Grice, why are you teaching me a new method if we're doing the old stuff? Well, let's look at another way. I can do this if there is no linear term. I can do the inverse operations. Is there a linear term? Nope. So if there's no linear term, that means I can do inverse operations. So to get rid of the square, I'm going to take the square root. Those cancel. It's a positive 16, which means I'm going to have two solutions, and that would be plus and minus 4. The nice thing, we got the same answer, guys. Let's look at number 2. once again, I'm going to see if I can factor it first. So I would add 25 to both sides. That cancels. To get x squared plus 25 equals 0. This isn't the difference of two squares. It's a quadratic binomial. It's addition and not subtraction. So I can't do anything else with this. Okay, this can't be solved by factoring. Okay, sorry, that's really slappy. But let's see. Can I solve it by doing inverse operations? Is there a linear term? Is there just an x line around there? Nope. Since there's not, that means I can do the square root. Okay? Now, can I take the square root of a negative? Plug it into your calculator and check. No, you can't. So the answer to this one is no real solution. Now, the point of us doing this, guys, take a look how many steps it took me to solve it on the left and how many on the right. Once again, how many on the left and how many on the right. If you can solve it using inverse operations, it is a lot faster. You do not have to do both methods, okay? So if there's no linear term, don't even bother. For number 3, no linear term. Okay, so we use inverse operations. I would want to square root both sides. It's a positive number, so it's going to be plus and a minus. And what is the square root of 37? I get a big answer, 6.082. So 6.082. Now the direction said to round to the nearest hundredth or the second decimal place. I'm rounding. It's going to be plus or minus. 5 or more, raise the score. 4 or less, let it rest. So we get x is equivalent to plus or minus 6.08. Number 5. Is there a linear term? No. No linear term means inverse operations. So the first thing I'm going to do is cancel my subtraction with addition. I'm going to add the 36 to the other side. And we get 6x squared equals 36. I need to cancel my multiplication with division. And we get x squared equals 6. And then the next step, I take the square root. Okay? So the square root of 6, 2.449. So it's going to be plus or minus 2.449. Once again, 5 or more, raise the score. 4 or less, let it rest. We're rounding. It's going to be plus or minus 2.45. Okay? Well, guys, I'm going to stop right there for the first video because I still have to go through the back of the notes, and we're already just about 20 minutes in. Okay? So if you have any questions on the first page, come see Ms. Carranza or myself. Otherwise, video 2 will start as soon as you click on video 2. Thanks for watching.